right. So sometimes using these sum and difference formulas requires us to be a little bit flexible in our thinking, and it's especially important to be able to think with fractions. So cosine of 105, well, that one's not so hard because that is pretty easy to think about being 60 degrees plus 45 degrees. So using my formula, I know if I take the sum of cosine, then that's going to be the difference of these two terms. So I'm going to get cosine of 60, cosine of 45, minus sine 60, sine 45. I can also reflect a bit that this angle, 105 degrees, is an obtuse angle. So I know my cosine value should be negative because I'm thinking x. All right, so knowing that, cosine of 60 is a half, cosine of 45 root 2 over 2, minus sine 60 is root 3 over 2, sine 45 root 2 over 2. And I hope that you know your unit circle well enough that you were as quick as that as I was. So this is going to be root 2 minus root 6 over 4, which is in fact negative, so it makes sense. All right, 7 pi over 12. Well, that's going to be the same thing as something over 3 plus something over 4. And I know that that's just going to be pi over 3 plus pi over 4. So thinking about my common denominator, 4 pi over 12, 3 pi over 12 is my 7 pi over 12. So coming up to my sine rule, sine says that sine of a sum is the same as sine of the first angle, cosine of the second, plus, so the signs match this time, sine of the second, cosine of the first, and the order doesn't actually matter which way I write these. So I'm going to end up with the same sum down here either way that you put your angles. All right, sine of pi over 3, that's my tall angle. That's root 3 over 2. Pi over 4 is my middle angle. Middle angle. Oops, that should be a 2. And then tall angle, so cosine is short. And I get root 6 plus root 2 over 4. Now, this is not always going to be the same solutions. We're going to see some other ones. So let's think about up here, 19 pi over 12. Well, 19 pi over 12, if I'm thinking about that, I think that 19 pi over 12, well, that's the same as pi plus 7 pi over 12. Well, I know that the 7 pi over 12 was pi over 3 and pi over 4. So I don't want to have 3 sums, though, because that just means I have to do my sum formula twice. So instead, I'm going to take this pi and add it either to the pi over 3 or the pi over 4. So I'll just pick the pi over 3. So then I'll get 4 pi over 3 plus pi over 4. And then I can go back and check myself, making my common denominator of 12. I'll have 16 here. I'll have 3 over here, which will give me 19 pi over 12. So now I can use my tan formula. I'm going to take this and shrink it down a bit so I have some space. All right, so my tan formula says tan of 4 pi over 3 plus, I've got this plus there, tan of pi over 4 all over 1 minus, taking the top one because I've got the plus there, tan of 4 pi over 3 times tan of pi over 4. All right, 4 pi over 3, that's a quadrant 3 angle, so tangent is positive. It's also my tall angle, so I know it's the bigger ratio, so it's going to be root 3 over 1. So I'll get root 3. Tan of pi over 4, that's quadrant 1, that's positive, and that's just 1 over 1 minus. The nice thing about tan is once I have these, I just multiply them together, root 3 times 1. So I get root 3 plus 1 over 1 minus root 3. And this does not simplify any further, so don't be fooled.